Hello everyone. Today we're going to go over how to drive the 7 segments on an FPGA like this. Show you. So I'm going to explain how to make any numbers you want very easily. More specifically, I'm going to give you a Verilog module that allows you to pass in a 32-bit number, BCD, that will drive these two vectors to create the numbers on the segments that you want. So right now, this is the value of BCD. So it generated that result you saw. This video, it's going to come in two parts. In the first part, I'm going to explain how the 7 segments are wired and how these two vectors need to be driven to get the values you want to show. That's mainly to help you understand how the module works, like how it needed to be designed. But if you want to just see how the module gets used, just skip to the later half of the video where I show you how to modify it. Just change the numbers. And all the code is provided in the video description. Okay. But anyway, the 7 segment display has only two inputs. It has a vector containing A, B, and all these things. And then it's got an enable vector. And when this vector has one of its elements as 0, that means to turn it on. If it's 1, it means it's off. So if we want to make the number 2, we have C as 1, F is 1, and DP is 1 to turn those three off, and have the rest 0 to have it be on. And the enable would need to be 0, 2 to have it be enabled. But that's just for 1. As you noticed, there's actually 8. There's actually 8 of them. And all 8 have different enables. So that's its own vector, enable 0 to 7. But they all share the same input vector, A to G plus DP. What that means is, if you were to drive the value for 2 and have all the enables as 0, then you would just get 2s everywhere. And the only way to fix that, like if you want to display a number like 792, what you have to do is have only enable 0 shown. Like you have to have enable 7 to 1 as 1, so they're off, enable 0 as 0, so then only that one's active, and have this vector be what this vector inject the needed values to display 2. Then what you're going to do to just show 9 is you're going to quickly set enable 0 to 1 and then change enable 1 to 0. So then this one becomes activated. And then you're going to change these signals to drive the value to be 9. And then to drive 7, you're going to make enable 2 be active, the rest unactive, and then change these values here to show 7. And if you alternate between that fast enough, it's going to look like all 3 are showing at once, when in reality only 1 is showing at any given time. But because it's going so fast, our eyes will it will look to our eyes as if they're all on at the same time. And the speed by which you change the two vectors to go from this result to this result to this result is important. If you go super fast, like if you go at 100 megahertz, nothing will turn on because the values will be changing so quickly that the 7 segments will not have time to drive their values. But if you go too slow, then you'll visibly see it changing. So that won't be good. So yeah, this module here that I'm going to show you how to use, you input a BCD containing the 8 numbers you want to display, and it will automatically drive this value, this vector, and the enable vector to show it. So if BCD is equal to all these things, you'll get the value that you saw earlier. So this is it right now. It's my top level module where I'm instantiating that module. These are the two outputs, so nothing's controlled there. This is just the clock. And then this is the input for this demonstration, which is I manually set it to those numbers, which you can clearly see. So 18299.725 is showing, just like we have here. So let's say we wanted to display a different number. Well, let's say we wanted to change this to 5. And this one is 9. And this one is 7. And then this one is 7. And this one is 0. So we want to display that instead. Oh, let's change this one to 3. Yeah, let's say we want to display that instead. It's as simple as saving, generating the bit stream, and it will do it. Alright, I'm going to skip to the future right now. Alright, so the bit stream is generated. So right now it's the old value. We're going to program the device and it's going to change. So there we go. Now it's this new value that we specified right here. Now let's say we want to one important thing is only the decimal showing on the third one. 0, 1, 2, so the third one. And that's because here we specify DP as 0, so it gets driven high. And in all the other places it's driven low by having it set to 1. And let's say we want to not display this fourth one. What we would do, 0, 1, we go to this one, change the enable to be like this. So now if we generate bit stream, it'll not show that one. So we're going to skip to the future now. Alright, so the bit stream is generated, and now we're going to program the device. Now let me bring it up. So now this one is not showing anything. And remember, that's because we made the enable all ones. If we want to re-enable it, we go to the fourth one and re-enable that. So then now it'll show again. And so we have the option to make any one of these. If special case is 0, it'll show these depending on what digit is. But if special case is 1, it will show a negative sign. If we want to show different symbols, we can add a case for if special case is equal to 2, drive G2A what it would need to be to make different symbols. So let's say we want to have there be a negative sign at the very front. Change this to 1 and then generate the bit stream. And hold on. And normally you can choose to have special case be a register, or you can make it be an input. So then a different circuit can choose how it gets driven. Right now I just have it like this, where it's a register internal, but it's probably better to have it be an input, where like you can have a module say display a negative number or not a negative number. So it's better to have it be an input, but for right now it's a register. So let's generate the bit stream so you can see the negative sign show. Alright, so the bit stream is generated, and now this is what's showing. And as you can see, there's clearly a negative sign there, just as we wanted. So based on what you've seen, you should feel completely comfortable on modifying these values, modifying things in here to display whatever numbers you want on the 7-segment display when any conditions you need are true or untrue. So that's all for this module, this video. The code is provided in the video description, and you should be able to use this to display any numbers you want in your projects. In the next video, we're going to discuss how to display the output of an arithmetic circuit using a BCD module.